Hi, in this video we're going to have a look at writing equations to represent combustion reactions. This particular video I'm only going to show you 3 examples of different types of combustion. So we've got complete combustion and then we've got 2 different equations for incomplete combustion, and I'm just going to show you a simple version so that you can then go away and try it with more complicated alkanes. So all 3 of the examples that I'm going to show you are going to use methane. So methane is CH4. And it has the displayed formula, C in the centre, 4 single covalent bonds going to 4 hydrogen atoms. So we're going to combust methane. The first question, it's question 1 on the activity sheet. So I've got question 1 up in the corner, asks for complete combustion. So if we break this down, we know that methane is CH4. Combustion means reaction with oxygen, or burning, it's the chemical term for burning, and complete means when you react methane with oxygen, you have enough oxygen to be able to produce carbon dioxide, and because there's some hydrogens here as well, not only will you get carbon dioxide, you'll also get a hydrogen oxide, so that's water, H2O. It's worth noting, if you started with a fuel that only had carbon in it, so if you used coal rather than methane gas, you couldn't produce water because you wouldn't have any hydrogen atoms to react with the oxygen, and in that case you would only get carbon dioxide if you just burnt coal rather than methane. Okay, so that's breaking down the question. That's a really good idea, and you could do that with all of your combustion reactions. What do we mean by the term complete? Tells you what it's going to produce. What is combustion? Tells you what the other reactant is, and what does this reactant look like so that you can write its molecular formula. So now that I know what the question's asking me, I can turn this into a symbol equation. Okay, so here's my symbol equation for this reaction. I've got my fuel, which is methane, CH4, oxygen, which is O2, and it's producing, because it's complete combustion, carbon dioxide, CO2, and because there's some hydrogens in the fuel, it's going to make water, H2O, as well. Simple things to make sure that you're getting right is that all of my elements begin with a capital letter, so all of these symbols are a capital letter, and especially places here where a capital C and a small c look the same as each other, a capital O and a small o look the same. I try to make sure that these are the same size as each other so that it's clear that they're both capitals, rather than one capital and one lowercase. The other thing is that your numbers here should be subscript, which means they should be small and at the bottom, not small and at the top. Charges in chemistry go at the top, but the numbers representing how many atoms are in a formula have to be at the bottom, so make sure that you don't make any of those silly mistakes. Now, the other thing that I've done when I've written out this equation is I've tried to leave a bit of a gap before the formula for each of the chemicals that's involved, and that's because this equation is not yet balanced and we need to make sure that it does. So most of this video is going to be on balancing equations. It's just a specific type of equation where we're reacting a fuel with oxygen. Okay, so I've just moved everything over to give myself a little bit more space, but all the information is still there. Now I'm going to show you my method for balancing equations to make sure that you kind of can't go wrong, because it's dead easy to make a mistake with balancing equations. So I've got my equation, and I've got all of my formulae of my reactants and my products. So what I do is I take each chemical in turn, each reactant or product, and I write down what's in it. So CH4, methane, has a C and 4 hydrogens. It's got 1 carbon and 4 hydrogens. And once I've written that out, I put a box around it to protect it. Okay, so I don't want to change that formula. Methane is always CH4, that's why I drew it like that up here. So I can't go changing this formula at all. It has to be 1 carbon and 4 hydrogens, otherwise it's no longer methane and we get the question wrong. So this box protects my formula and keeps it as CH4. So I'm going to do that with all of the other chemicals. So I've got O2, which is made out of 2 oxygen atoms, and I'm going to put a box around that to protect it. Carbon dioxide is 1 carbon and 2 oxygens, and I'll put a box around that. And water is 2 hydrogens and 1 oxygen, and I'm going to put a box around that. So that's one stage in balancing equation. The other really important stage is to know where your reactants and your products are and to not lose track of that. In this one, it's nice and easy because it's kind of symmetrical. I've got 2 chemicals on the left and 2 on the right, but sometimes you don't, and it gets a little bit tricky as to where your reactants and your products are. So to make sure I don't forget, I'm going to split my equation down the arrow so that I know what's going in and what's coming out without even having to think too much about it. I can see it really clearly, what's going in, what's coming out. Okay, so I've got my formula. I've protected my formula so that I can't change them. Now, the aim of balancing an equation is to make sure that every atom that goes in also comes back out again. Atoms cannot be created, so they can't turn up out of nowhere, and they can't be destroyed, so they can't just disappear. They can only be rearranged, so they still have to come out the other side somewhere. So however many carbon atoms I've got here, I should have the same amount here. However many hydrogens I've got here, I should have the same amount here, and however many oxygens I've got here, I should have the same amount here. And that is the puzzle of balancing an equation. So the next step is to check each element in turn and make sure that we have the same number on the left as is on the right. So I'm going to go for carbon first because that's the first element in my equation. Carbon, I have 1 here and none here, so I've got 1 carbon on the left. On the right, I've got 1 here and none in here, so I've got 1 on the right. So I've got 1 carbon on the left and 1 carbon on the right. That's fine. That 1 atom has gone in and it's come back out the other side rearranged, joined to other atoms that it wasn't joined to before. So that's balanced for carbon. Looking at hydrogen, we have got 1, 2, 3, 4 hydrogens on the left and none in there. So 4 on the left, and on the right, 1, 2. So we've got 4 H's here and 2 H's here. Let me just write that down so that we can see. Okay, now this needs balancing because this isn't the same on both sides. So the rule is you can have multiples of any chemical that you like. So the chemicals we've got available, that one, that one, that one, or that one. You can have as many of those as you like, but you can't add in anything different. Okay, you can't change what's inside these boxes because those formulae are set formulae. You can't edit them, but you can have more boxes if you like. So which of the 4 boxes should I draw again so that I end up with the same number of hydrogens on the left as on the right? Pause the video, have a look. Box 1, box 2, box 3, or box 4. Which box should I draw again to make sure that the hydrogens are balanced? Pause the video, have a think. Okay, if I want 4 hydrogens to be on the right to match my 4 hydrogens that are on the left, it would make sense to put more hydrogens on the right-hand side. This box doesn't have any hydrogens in it, so I'm not going to draw that one again. This one does, so I'm going to draw another one of these. So, there we go. We've now got 2 lots of water, or in chemical terms we can say 2 moles of water. But if you've not done quantitative chemistry yet, don't worry too much about that word. You can just say lots of for now. 2 lots of, or 2 molecules of water. Let's double check our hydrogens now. So on the left we've still got 4 hydrogens because we haven't changed anything, so that's correct. On the right we have now got, none in there, 1, 2, 3, 4. We've now got 4 hydrogens on this side, so I'm going to change that to a 4. So I've got 4 on the left and I've got 4 on the right, so hydrogens are now balanced. So that's really good. Okay, now I can go on to my oxygens because my carbons are balanced and my hydrogens are balanced. I just need to check my oxygen atoms. So again, I have a look at how many oxygens are on the left-hand side and how many are on the right-hand side, and take care because you've got to check the whole left-hand side and the whole right-hand side, not just one box. So on the whole left-hand side, I have 2 oxygen atoms and they're in there. So I've got 2 oxygens on the left. On the right-hand side, I've got 1, 2, 3, 4. I've got 4 on the right-hand side, so let's write that one down. And we're in a similar situation as we were with the hydrogens. We've now got an imbalance. So what this looks like at the moment is that you've put 2 hydrogens in and 4 have come out, so you've made 2 two oxygens out of nowhere. You can't put 2 oxygens in and get 4 out, so we need to balance that. So which side do we need more oxygens on? We need to increase oxygen on this side to get it to match that side. So which box would you draw again? We can draw this box, this box, this box, or this box again. Pause the video now, have a think, and decide which box you would draw to make sure that the oxygens are balanced on each side. So we want more oxygens on the left-hand side. It would make sense to draw another box that's on the left-hand side. This one's got no oxygens in it, so we leave that one as it is. But this one has 2 oxygens, so we can draw that one again. So if I draw that again, and I have to draw the whole box, I can't just pick and choose to draw the whole thing. There we go. Let's double check. How many oxygens have we now got on the left? 0, 1, 2, 3, 4. We've got 4 on the left. And how many have we got on the right? 1, 2, 3, 4. So we've got 4 on the left and we've got 4 on the right. That means that we are now balanced. Okay, so we've been through every element that is appearing in our equation: carbon, then hydrogen, then oxygen. When you've gone through and you've balanced each of them, it's a really good idea to quickly go through every element again, because by changing one element, you might have accidentally edited another one. So I'll show you an example of that next. So a quick check. Let's check carbons again. For carbon, we have got 1 on the left and none there, and on the right we've got 1 there and none there. So we've got 1 on the left, 1 on the right, so that balances. Let's have a look at hydrogen. Hydrogen, we have got 1, 2, 3, 4 on the left, 1, 2, 3, 4 on the right. So we've got 4 on the left and 4 on the right, so that balances. And for oxygen, we have got 1, 2, 3, 4 on the left, 1, 2, 3, 4 on the right. So that also balances. So we are done. Okay, final and most important step, because you won't get any marks for this question up to this point. This is just you working out to help you to get to the right answer. Final part is to go back, and these gaps that I left, we need to fill in any that need big numbers. So how many boxes with methane in do I have? How many methanes have I drawn? Just the one, so I don't need to write anything there. Just one of those is fine. How many oxygens have I got all together? So how many boxes containing oxygen? Or how many lots of or moles of oxygen? 1, 2. 2 lots of oxygen, so the oxygen needs a big 2 to say 2 lots of that. Okay. Carbon dioxide, I've only drawn it once, so we don't really use ones in chemistry, so we just leave it blank and we just say CO2. And the water, we've drawn twice, we've got 2 lots of it, so we need a number here to represent that, so we've got 2 lots of water. So now we can take all our working out away as the final answer to that question. So 1 molecule of methane will react with 2 molecules of oxygen, producing 1 molecule of carbon dioxide and 2 molecules of water. Okay, and finally, just to prove that this is correct, I've given you diagram forms of these molecules. So the methane is represented here, where the black one is the carbon, and we've got 4 white hydrogens. And then we've got O2 here, and we've got 2 lots of it, so I've drawn it twice. So in this reaction, what we're doing is, rather than creating new atoms or destroying the ones we already have, we just take these atoms and we rearrange them, and we're able to make these atoms. So just to show you how that works, I will rearrange them. I won't add anything new. I will just move them around and turn them into carbon dioxide and water. There we go. So there's your final answer. That one is a complete combustion because we've made carbon dioxide and water. It's combustion because we've reacted it with oxygen, and we've used methane, which is CH4. So for our next example, we will have a look at incomplete combustion. Okay, so the next example, question 7 on your sheet, incomplete combustion of methane making carbon monoxide. And I've specified which product I want you to make because there are different types of incomplete combustion that you could write an equation for, and I'll show you another example next. So again, let's break down the question and figure out what it's asking us to do. So we know that combustion means to react with oxygen, and we know that methane is CH4. Okay, the incomplete part of it means that when you react the fuel with the oxygen, there's not enough oxygen to produce carbon dioxide and water, so instead you produce carbon monoxide and water, or just carbon and water. And in this case, it particularly wants the equation that shows carbon monoxide. Okay, so incomplete combustion is when there is insufficient oxygen to produce carbon dioxide. Okay, and just to finish off our labelling, carbon monoxide is CO, and that's going to be one of our products. So again, I'm going to write this in a symbol equation, and then we'll have a look at balancing it. So here's my symbol equation. Again, I've left gaps all over the place because I want to make sure that when I come back at the end, I can fill in any big numbers here that I need to balance the equation. Okay, I'm going to do exactly the same thing again to make sure that I don't change this formula or this formula or this one or this one. I'm going to write down which atoms are in each formula and put them in a box to protect them. Okay, the other thing I'm going to do is make sure that I know which is my left-hand side and which is my right-hand side, so which are my reactants and which are my products, by drawing a line down the centre there so I can easily see what's going in and what's coming out. Okay, and then we go through each element in turn and make sure that it's balanced on the left-hand side and on the right-hand side. So starting with carbon on the left-hand side, I've got 1 carbon and it's in this box, don't have anything over here, so 1 carbon on the left-hand side. On the right-hand side, I've got 1 carbon here and none here, so I've got 1 on the right-hand side as well. So for carbon, I am balanced. For hydrogen, I have 1, 2, 3, 4 on the left-hand side and 2 on the right-hand side. So here we need to balance it, and we've seen this exact balancing in the previous example. I need to put more hydrogens onto the right-hand side. That shouldn't be an O, that should be an H. Don't know why I did that. I want to put more hydrogens on the right-hand side to make sure that they match with these. That's an important point. So whenever you've got an imbalance in elements going in and elements coming out, or atoms going in and atoms coming out, you always want to add more onto the side that doesn't have enough. You can't take any away. So if I look at this 4 hydrogens and 2 hydrogens, some people would be tempted to try and take away some hydrogens like that. But remember the rule, you cannot change what's inside a box, because if you change what's inside a box, you're changing the formula and it wouldn't be CH4 anymore, as we can see here. So you can't do that. The only way you can balance stuff is by adding more onto one side or the other. Okay, so we need to add more onto the right-hand side. My hydrogens on the right-hand side appear in this box, so this is the box I'm going to draw again. So there we go, we've got second water molecule. So let's recount our hydrogens on the left and hydrogens on the right. On the left, we've got 1, 2, 3, 4, which is still the same here. And on the right, we've now got 1, 2, 3, 4. So by drawing that box again, we have balanced that to get 4 on the left and 4 on the right. So that's perfect. Okay, going on to our third element that we've got is oxygen. So we need to check that the oxygen atoms on the left is the same number as those on the right. Now this is where this one gets a little bit more interesting. So on the left, I have got 1, 2 oxygens. So 2 oxygens on the left. And on the right, I've got 1, let's count them in the boxes instead, sorry. 1, 2, 3. I've got 3 oxygens on this side. And that's not as simple as it has been before, because we've always just been able to double up a box. So I want to get 2 on the left and 3 on the right to be the same number. Okay, so where do I need more oxygens? I need more on the left at the moment, because I've only got 2 on the left as it stands. So let's add more oxygens on the left. Which box on the left would I draw to give me more oxygens? It's going to be this one. So let's draw this box again. Now we've got some more oxygens. Let's recount. On the left, we've now got 1, 2, 3, 4 oxygens. So I'm going to change this. We've now got 4 oxygens on the left, but we've still got 3 here. So where do we need more oxygens, on the left or on the right? Now we need more oxygens on the right-hand side. So this is where it becomes a little bit like a Rubik's Cube, and every time you fix one thing, it affects something else. So we need more oxygens on the right, and there are 2 places that we could add oxygen. We could double up this box, and that would give us another oxygen here. Or we could double up this box and it would give us another oxygen here. So there are a number of things that we could do, and it's hard to tell which one would be best. But either way, we're going to end up either messing up our carbons by adding another oxygen here, or messing up our hydrogens by adding another water here. So let's take the carbon monoxide, because you can do a bit of trial and error with this, and let's double up the carbon monoxide. So we're going to take that box and double it up. Okay, now we need to change our numbers. I'm going to neaten this up slightly so that we can see what we've got. Okay, so we've now added some more oxygen on the right-hand side. So our oxygens on the right are 1, 2, 3 and 4. So we can change this over here. We've now got 4 oxygens. Now this is looking really good, because if you look at the bottom, 1 carbon, 4 hydrogens and 4 hydrogens, 4 oxygens and 4 oxygens. Some people might get to this point and go, yes, we're balanced. But remember what I said in the last one. Once you've done all of the elements, it's worth going back and checking that you haven't messed anything up along the way. And some of you will have noticed already, as I said, we've messed up the carbons a little bit. Okay, so carbon. Let's go back to carbon, because we've done something here with carbon. On the left, we have still got 1 carbon here, so that's fine. But on the right, we've now got 2 carbons, so we need to change this. So this is going to be 2 carbons. Now we've got 1 on the left and 2 on the right. We need to balance that. Which side do we need more carbons, left or right? We need more carbons on the left. So of all of the boxes on the left-hand side, which box would you draw again to give us more carbon atoms? It's going to be this one. So we'll take that box and we will draw that again. Now we've got 2 carbons on the left and we've got 2 carbons on the right. So you can see how this is getting really messy now, because look how many hydrogens I've just added by doing that. Anyway, we've put our 2 carbons there, so we've now got 2 carbons. So your carbons are back to being balanced again, which is great. But your 4 hydrogens on the left and your 4 hydrogens on the right are a big mess now, because actually on the left-hand side, you've now got 8 hydrogens. So let's change that. We've still only got 4 hydrogens on this side. Okay, so let's fix hydrogens then. We've got 8 on the left and we've got 4 on the right. Which side do we need to add some hydrogens to? And which box would we draw again? We need more hydrogens on the right, so we're going to draw some more of these waters. So let's take the water and draw it again. There we go. Now you can see, if you're a quick thinker, that we've got 6 hydrogens on the right-hand side, but actually we wanted to get it up to 8, so we have to take another water and put that on that side as well, because that will take us up to 8. So we've got 1, 2, 3, 4, 5, 6, 7, 8 on this side. 1, 2, 3, 4, 5, 6, 7, 8 on that side. So let's change our numbers. So we've now got 8 and 8. So our hydrogens are back to being balanced again, which is great. But now we've messed up our oxygens. So let's have a look how many oxygens we've got. Well, on the left-hand side, we've still got those 4, so that's fine. But on the right-hand side, we've now got 1, 2, 3, 4, 5, 6. So we've now got 6 oxygens on the right-hand side. Okay, so this little tally at the bottom is really helping me to keep track of what I've balanced and what I haven't. So I can see that I need more oxygens on the left-hand side, so which box would I draw again? Well, the only one that's got any oxygen atoms in it is the one here, so I'll draw that one again. By doing that, how many oxygens do I now have on my left-hand side? 1, 2, 3, 4, 5, 6. So this needs to change to a 6. Okay, so I've got 6 oxygens on the left and 6 on the right, so they look balanced. But because this is very tricky, I just want to make sure that I haven't accidentally messed something up along the way that I haven't kept track of. So just to finish off, I do one last check through each of the elements. Carbon, I've got 2 on the left and I've got 2 on the right, so that's fine. Hydrogen, I've got 8 on the left and I've got 8 on the right, so that's fine. Oxygen, I've got 6 on the left and I've got 1, 2, 3, 4, 5, 6 on the right, so that's fine. So it does balance, and I am happy with it. That's our working out complete. Don't forget the final step. We now need to say how many of each of these boxes we have got by putting some big numbers in front of these chemicals. So, how many times have we got the methane box? Twice, so we put a big 2 there. How many times have we got the oxygen box? 3 times, so we put the 3 there. We've done carbon monoxide twice, and we've done water 4 times. And once we've got to that point, we can get rid of all of our working out, and there we have a final answer. So the incomplete combustion of methane making carbon monoxide, and of course we're going to make water because we've got some hydrogens here, so we had to make water as well, is 2 molecules of methane reacts with 3 molecules of oxygen to make 2 molecules of carbon monoxide and 4 molecules of water. Quickly show you that with diagrams, and then we'll move on to our third and final example. Okay, so in diagram form, I've drawn methane twice. So we've got the carbons in the centre with the 4 hydrogens around the outside. And then I've got an oxygen molecule, but I've drawn that 3 times according to the balancing of our equation. So I should be able to take all of these atoms and rearrange them perfectly to make 2 carbon monoxides and 4 waters. So let's take those and have a look at what we can make. So there's our 2 carbon monoxides and what's going to be 4 lots of water, or 4 moles of water. There we go. So that proves that the balancing is correct. Let's have a look at the final example. Okay, question 11 on your sheet, incomplete combustion of methane making carbon this time. So we're not actually going to make carbon monoxide. We've got even less oxygen available, so this time we're just going to make carbon, and we're going to end up with some water as well because methane has hydrogen atoms in it. So again, good practice to break down the question, remind yourself of what each of these terms mean. Okay, so again, combustion just means reaction with oxygen, so we know that oxygen is going to be a reactant. The other reactant is methane, which we know is CH4, so we've got our left-hand side. Incomplete tells us that there is insufficient oxygen or a limited supply of oxygen, and that means that it's not going to be able to make carbon dioxide, so it will either make carbon monoxide or just carbon. And in this particular question, it makes it a bit clearer that we want the equation for the one that produces carbon alone, rather than carbon monoxide. So I'm going to write this as an equation. Again, I've left some gaps for our big numbers because that's how we get our final marks for this question. And I have put our reactants, methane, the fuel, and oxygen because it's combustion. And I've got our products on the right-hand side, carbon, because it's what the question asks you for, and water, which has to be made because there are hydrogen atoms in the methane molecule and they have to react with the oxygen as well. So in full complete combustion, usually the carbon would react with oxygen to give you carbon dioxide, and the hydrogen would react with oxygen to give you water. But because we've got a limited supply, in this case the carbon's not able to react with oxygen, so it just is left as carbon, but the hydrogen is what reacts with oxygen, and that's why we get the water. That's where that comes from. Okay, so same as before, we're going to find out which atoms are in each of these formulae, and we're going to protect that formula with a box so that we're not tempted to change it. Okay, so there's our formulae. Again, I'm going to remind myself of where my reactants and my products are, so what's going in and what's coming out by drawing a line through the arrow, and I can easily see what's going into the reaction and what's coming out at the end. Now we can go through each element in turn and identify how many we've got going into the reaction, how many we've got coming out of the reaction, and balance any that aren't already balanced. So let's start with carbon. Our carbon atoms on the left, we've just got the 1, and on the right, we've got 1 here. So carbon atoms are already balanced for now. We might change that when we're editing other things, but for now they are balanced. Let's go on to hydrogen. We've got 1, 2, 3, 4 hydrogens on the left, and 2 hydrogens on the right. So the hydrogen atoms are not balanced and we need to sort that out. So first question to ask yourself is, do we need more hydrogens on the left-hand side, or do we need more hydrogens on the right-hand side? Well, at the moment we've only got 2 on the right-hand side, so we need to put more on the right. Which box are you going to draw again out of the ones that are on the right? Well, this is the one that's got hydrogen in it, so we're going to take that box and we're going to draw it again. We're going to produce 2 lots of water now. Quick check, 1, 2, 3, 4. We've got 4 hydrogens still on the left, but now we've got 1, 2, 3, 4 on the right. So we can change this. And they now balance. So our carbons are fine and our hydrogens are fine. Let's have a look at oxygen then. On the oxygens, we've got 2 on the left and we've got 2 on the right now, thanks to us adding another box of water. So we've got 2 on the left and 2 on the right. So the oxygens are also balanced. So now it looks like all of our atoms are balanced. Before we finish, we're going to make sure that they definitely are. We haven't accidentally changed something without noticing. So quickly, carbons on the left, 1, on the right, 1. Good. Hydrogens on the left, 4, and on the right, 4. So that's good. Oxygens on the left, 2, and oxygens on the right, 2. I've confirmed it's definitely balanced. And the final step is just to put those big numbers into the equation. So how many times have we drawn the methane box? Just once. So we don't need any numbers to go here because we've already got 1. We've drawn oxygen only once, so we don't need to put any numbers here because this shows that we've already got 1. We've got 1 carbon, so we don't need to change that. But we've now got 2 waters, so we do need a big number 2 there. Then we can get rid of all of our working out. Obviously, if you're in an exam, leave your working out, it doesn't matter. As long as it's clear what your answer is, you don't need to waste time getting rid of all of this. But now you can see quite clearly what the final answer to this question is. I'll just draw that arrow again. There we go. So the incomplete combustion of methane for the reaction that makes carbon, so solid carbon rather than carbon monoxide, is 1 lot of methane reacts with 1 lot of oxygen to make 1 lot of carbon and 2 lots of water. Or 1 mole of CH4 reacts with 1 mole of oxygen to make 1 mole of carbon and 2 moles of water. And as a final last step, I'm going to show you very quickly in diagrams just to prove that you can rearrange the atoms that are on the left to produce the atoms that are on the right. Okay, so we've got the diagrams on the left. So this is our methane molecule, the black one's the carbon and 4 white hydrogens. And then we've got a molecule of oxygen represented by 2 oxygen atoms covalently bonded together. So can we take all of those atoms and rearrange them to make what's on the right? So let's take the carbon on its own and then start building some water. So we've got HHO, HHO, and we have managed to turn methane and water into 1 carbon, which is here, and 2 waters, which are here. So that proves that your balancing is correct. So hopefully that shows you a kind of foolproof method of how to balance any equation, doesn't have to be a combustion reaction, by writing down which atoms are in each formula, putting a box around them so that you're not tempted to change them. The problem with doing it without the box method is that some people, if they've got a substance such as H2O and they go, oh, I need more oxygens on this side, the temptation is to go, right, well, let's just add another oxygen by doing that. However, if you have got HHO and you've put it in a box, you've protected that formula and you know that you can't then add another oxygen into that box because you cannot change what's inside the box. All you can do is add more of the same boxes that you've already got. So it is a really good method. So if you're somebody who struggles with balancing equations, that might be something to practice on each of the balancing equation questions that you are asked to do, because I don't think you can fail with it if you stick to the rules. Okay, so now it's your turn to go away and have a look at the activity that I've left for you so that you can complete some combustion reactions of your own. The only difference with any other questions will be that they won't be methane anymore, they will be different alkanes, so you need to know that kind of ethane is C2H6 and propane is C3H8 and things like that. Apart from that, do exactly the same thing. So the steps that I've taken is to label the question with what each of the terms is telling you, because each bit of this gives us a clue as to what to write for our equation. Then write a symbol equation. Then write what's in each formula underneath. Put a box around each of them to protect the formula, and then go through each element in turn, trying to get them to balance. If they don't balance, you cannot change what's inside a box. You can only add more boxes. And when you've got all of the boxes to balance, You then need to go through and add your big numbers to show how many of each you've got. And this is your final answer.